Hey guys, so I told you that we were going to look at more examples of limiting reactant problems. So this video has two examples worked into it. So we're going to just jump in and start the first one. Determine how much P4O10 is formed if you combine 25 grams of P4 and 50 grams of O2. So we already have this balanced chemical reaction, and we have to start with the same steps we saw in the last video, and the first step is determine the number of moles of each reactant present. So first we're going to look at P4. They tell us that we have 25 grams of P4, and one phosphorus has a mass of 30.97, so four of them have a mass of 123.88. This gives us a total of 0.2 moles of P4. Now we're going to do the same thing with O2. The problem says that we have 50 grams of O2. One oxygen has a mass of 15.99, so two of them have a mass of 31.98. When we divide those out, we have a total of 1.56 moles. Now I went through these two problems pretty quickly because these are things that you've seen before and we've already practiced with, and I hope that you don't actually have to see those steps. Now we have to write the coefficient ratio, so the ratio from the problem, and it's 1, 5, 1. There's a 1 out front, a 5 out front, and a 1 out front. Then we have to write two mole ratios. So we're going to take this 0.2, and since this is related to P4, we're going to place it in the first spot. So 0.2 is in the first spot. It is also in the third spot because those numbers are the same. And to get from 1 to 5, we have to multiply by 5. So 0.2 times 5 is 1. Now O2 is in the second spot, so I'm going to take this 1.56 and put it in the second location. And to get from 5 backwards to 1, we're dividing by 5. So 1.56 divided by 5 is 0.31. And the last spot is the same because those numbers are the same. Now we have to choose the mole ratio that has the smaller numbers, and that's actually this one. So P4 is our limiting reactant, and that's the one that gets used up completely. So I want to remember 0.2, 1, and 0.2 for the next slide since I kind of ran out of space. So what I'm going to do is actually erase what's currently on the screen, and I'm going to rewrite 0.2, 1, and 0.2 as our limiting reactant. So I'm going to erase all of that, and I'm going to rewrite 0.2, 1, and 0.2. So we're asking for how much P4O10 is formed, and that's in this third spot, so I know 0.2 moles is created. So 0.2 equals sample mass over the molar mass of P4O10, and 4 P's again has a mass of 123.88, 10 O's has a mass of 159.9, and when we add those together, there's 283.78 grams in P4O10. That means once we multiply through that the sample mass, or the mass that's created of P4O10, is 56.7 grams. So that answers the question that the prompt asked us. But again, if we want to compare the masses that we started with the masses that we ended with, we are going to have extra O2 sitting around. So from our first calculation, we had 1.56 moles of O2. We used 1 mole of O2 according to this new mole ratio. That means that there are 0.56 moles left over. So one more time, we're going to use the sample mass over molar mass calculation. And the molar mass of 2 O's is 31.98. And that means we had 17.9 grams of O2 left over. So we started with 50, and we have 17.9 grams that were untouched. So if we compare the mass before and after the reaction, all of our masses plus this 17.9 unused should add up to the same number. So here's our second example. And this example is slightly different than the ones that we've seen before because we have 4 chemical compounds in our chemical reaction. So in the end, we're actually going to ignore one of them for now. I may add it in later so you can compare the masses before and after the reaction, but for now we're just going to ignore it. but we still have to do the rest of the other steps. So we have to start with MgOH, OH2, and we have to calculate how many moles are present. So we were told that we had 50.6 grams, and the mass of MgOH2 added together is 58.26. So that's 1 magnesium, 2 oxygens, and 2 hydrogens. And this gives us a total of 0.87 moles. Now I'm going to do the same thing with HCl. We were told that we were starting with 45 grams of HCl, and the mass of HCl is 36.45. So 36.45 is 1 H and 1 Cl added together. And when we divide these out, we have 1.23 moles of HCl. Now we have to write our coefficient ratios from our chemical formula, and we have 1, 2, 1, 2. And MgOH is in the first slot, so 0.87 goes in the first slot, but it also goes in the third slot because those numbers are the same. Now to get from this number to this one, we multiply by 2, so 0.87 multiplied by 2 is 1.74, and that also goes in the last spot because these two numbers are the same. Now I'm going to do the same thing for HCl. We had 1.23 moles of HCl, and in our chemical reaction, HCl is in the second location, so I'm going to put 1.23 in the second spot. And since the second and the fourth numbers are the same, I'm going to rewrite 1.23, and to get from this number back to this one, we divide by 2, so 1.23 divided by 2 is 0.61, and that goes in the two other locations because they are the same number. Now compare the first numbers of each mole ratio, 0.87 and 0.61. 0.61 is smaller, so that means that HCl is our limiting reactant. So what I'm going to end up doing is deleting the rest of the slide and taking this mole ratio and writing it at the top. So we had 0.61, 1.23, 0.61, 1.23. Now the problem is asking us for how much H2O is formed. And H2O is in the last location, so I'm going to use this number of moles to find my answer. 1.23 moles is our sample mass over 17.99. That's 1 oxygen and 2 hydrogens added up. Now I'm going to multiply those two together and determine that our sample mass of water, or H2O, is 22.12 grams. So once this reaction takes place, we are going to use all of the hydrochloric acid, or the HCl, and we are going to create 22.12 grams of water. Now if I wanted to have you compare the masses before and after, we would then have to do the same calculation for the MgCl2, or the magnesium chloride, and then find the excess reactant left over and then add them all up. But at this point, I don't want to add that step in. So as far as we're concerned, we're done with this problem. We ignored this extra number because right now we don't need it. We calculated for the number of moles of H2O were created because H2O is the fourth location, and we could use our sample mass over molar mass equation to find that math. So again, when I see you tomorrow, we're going to practice with this stuff a ton. I'm going to be walking around answering your questions and hopefully minimizing any issues or concerns that we have. So limiting reactants, here are 2 extra sample problems, and we're going to go ahead and work with this tomorrow. See you then.